Good morning, everybody. Today we'll be discussing about blood groups. When we discuss blood groups, we have to remember two important terms. They are antigens and antibodies. Antigens are nothing but agglutinogens. And what are they made up of? They could be proteins, glycoproteins, or lipids. And the definition is substances which induce formation of corresponding antibodies when introduced into the body with which it reacts specifically. I would like to stress on the term with which it reacts specifically. Antigens can be classified into self and non-self. Coming to antibodies, they are also called as the agglutinins, and these are again nothing but proteins or immunoglobulins. So substances which are produced when corresponding non-self antigens are introduced into the body with which it reacts specifically are called as antibodies. It's always good to know about the history of anything that you're dealing with. So who was it who was interested in blood grouping? It was in 1900 that Karl Landsteiner, Viennese pathologist, actually discovered blood groups. He discovered 3 blood groups and named it as A, B and O. And his fellow colleagues De Castello and Stirling were the ones who discovered the 4th blood group and named it as AB. Now we have 26 blood grouping systems and 228 blood group antigens. And these are all proteins, glycoproteins or glycolipids. Some antigens are specific and some are seen even on other cells. And we have a system of antigens called as Levi's and Chido-Rogers system, and they are adsorbed from the plasma. Here is a list for you students about the different systems of blood group, that is ABO, RH, MN system, PI system, Kell system, Levi system, Duffy system and Indian system. Okay, we come to one of the most popular blood grouping system, that is ABO system. And like I said earlier, it was Landsteiner in 1900 who discovered this system. In this system, we have 2 important antigens. They are A and B. And also 2 important antibodies, that's anti-A or alpha and anti-B or beta. And based on the presence or absence of these antigens, we have 4 blood groups. That's A, B, AB and O. And ABO gene is located on chromosome number 9. And the precursor of this A and B gene is H gene, which is on the chromosome 19. And you will be seeing in future slides, when you see the structure of these genes, you realize that these genes encode for different enzymes, and these enzymes again add specific sugars. ABO antigens are basically oligosaccharide chains. So here is the written material for you before seeing the picture. A gene has an enzyme N-acetyl galactosamine transferase, which again attaches to N-acetyl galactosamine. And B gene has galactosyl transferase that attaches to galactose. And H gene, which is the precursor, has mainly fucosyl transferase. And Bombay blood group, they don't have this H gene. That's why we call them as HH, small h genotype. Here you can look at the pictures, the chemical structure of each of these genes. So first one is H antigen, which is the precursor. F is fucose. The G in a triangle is galactose. The G in a circle is N-acetyl galactosamine. And the G in a square is the glucose. And C is the ceramide. And the two purple blocks you see, they are the lipid bilayers. Now you can see the A antigen, wherein it has the H antigen, and it is again attached to G, which is in a circle, that is N-acetyl galactosamine. And now look at the B antigen. Here again we have the precursor H antigen. But see what is attached here. The G in a triangle. What is that? That is galactose. So you can see the pictures and see the difference between the structure of A antigen and B antigen. This law must be an important landmark while he was actually discovering these blood groups. And you cannot afford to forget this law, okay? So this is called as the Landsteiner's law. If an agglutinogen is present on the red cell membrane, the corresponding agglutinin must be absent in the plasma. If an agglutinogen is absent on the red cell membrane, the corresponding agglutinin must be present in the plasma. And while you state this law, you will have to state it completely. You cannot tell the first part and say vice versa, because it will not make sense. Because there are some blood grouping systems which will obey only the first half of the law and not the rest. So keeping this law in mind, I have made a table here which shows different blood groups and the antigens and the antibodies present. So for memorizing, you all be with me. Look at this. We'll take one blood group, that's A. If an agglutinogen is present on the red blood cell membrane, so we have A antigen here, that's the agglutinogen present. Then the corresponding agglutinin must be absent in the plasma. Look at that. We don't have A antibody there, isn't it? What we have is anti-B. So I hope you got the law. Take it for B. The antigen is B and the antibody is anti-A. And AB, it has both the antigens on the red blood cell membrane, that is A and B. So it's obvious that it has no antibodies in its plasma. And when we come to O, again we don't have any antigens in the membrane. So we have both anti-A and anti-B antibodies in the plasma. So we dealt with the antigens. Now what we have is ABO antibodies. And these are mainly IgM antibodies. And they develop over the first 3 to 6 months of life. And you all know there are two kinds of antibodies, that's warm and cold. ABO antibodies are cold antibodies. And how are they generated in the body? They arise as a result of exposure to ABO-like polysaccharides. They've seen that based on a lot of studies that A blood group is more prone for gastric carcinomas and O blood group people are more prone for peptic ulcers, more precisely duodenal ulcer. The next important system is Rh blood group system. It was Landsteiner and Wiener in 1940 who worked on this. This was seen, or the work was done mainly on Rh monk, that is rhesus monkeys, and that's why we call this blood grouping system as Rh blood grouping system. And this has a set of antigens, that is C, D and E. Out of all, it's D which is most antigenic. That's why when D antigen is present, we call the person as Rh positive. And if D antigen is absent, we call the person as Rh negative individual. And the most important applied aspect with respect to Rh is Rh incompatibility. This is also called as hemolytic disorder of the newborn, which is a very, very fatal condition. How and when does that occur? When an Rh negative lady marries an Rh positive husband and she has a baby which is Rh positive, the first baby is generally escaped from this disorder. But I will tell you it's not 100% because if the mother is previously exposed to Rh positive blood, then even the first baby can have this incompatibility. Just keeping in mind that she has not been exposed, the first baby is generally safe. So what happens when she delivers for the second time? And if the second time the baby is again Rh positive, because the antibodies are already produced, because during first pregnancy, first delivery, during parturition there is mixture of blood and the maternal body produces antibodies against these Rh positive blood. These antibodies during the second delivery can cross the placenta and it can destroy the RBCs of the fetus. So this is called as Rh incompatibility. And what are the features of it? Thing is erythroblastosis fetalis. Why erythroblastosis? Because so much of RBCs are destroyed that there is an urgent need for the production of RBCs, and hence there is a rapid production of RBCs which are immature. They are blast cells. That's why we call it as erythroblastosis. And the second feature is icterus gravis neonatorum. Icterus because RBC destruction leads to the production of bilirubin, and more bilirubin again gives an yellow discoloration to the skin and mucous membrane, which we call as icterus. And why gravis? Because it can be that severe that it will cross the blood-brain barrier and it causes kernicterus and it can lead to death. That's why it's gravis. And there is overall inflammation or edema of the fetus, which leads to hydrops fetalis. Here we have pictures of hemolytic disease of the newborn. So you can look at that. It's a stillborn baby. Now what are the functions at the last? It's for identification, isn't it? Blood groups are an important identification point. Whichever job or whatever ID you have, everywhere you mention your blood group. And blood transfusion. For any sort of medical emergencies, you have to have blood. And to transfuse blood, you have to know the blood group of the person and you can give him an identical blood group, and only then transfusion is possible. Crime investigation. So it's for finding out the culprit. You have your crime scene, and if you have blood somewhere near the crime scene, you can take the blood to the forensic lab, see what the blood group is, and you can easily tell who or who not the culprit is. And finally, paternity issues. It is going to help us by telling who not the father is and not who the father is. Okay, that means if a baby has O blood group, then we can tell definitely that the father is not AB. If a person is having AB blood group, then his child cannot be O. Similarly, if a person has O blood group, then his child cannot be AB. So this is for solving the paternity issues.